Okay, so what we're talking about is exponential equations. Exponential equations. Okay. And what we want to do, what is it, November, 18. What we want to do is make the same base. We want to get the same base. Okay? Now before I want to start, I just want to do just a really easy problem. 3 to the x equals 81. Okay? As an example, I want to start with this example. Okay? So, you know, before I taught you all this stuff, you might think, gosh, just, 3x divided by 3, divide by 3, but that's not how it works, is it? It's not 3x, right? It's different, isn't it? It's 3 to what power? This won't work. This won't work. It's 3 to what power, right? So what's x have to be in this example?
At 4.
It has to be 4, totally right. It has to be 4 because 3 to the 4th power is 81. Good. So we can't divide. We've got to go ahead and figure it out. And our chart showed us that, right? We were able to look at our chart. We found 81. So what we need to do is this. Here's our rule. Okay, our rule is this. Once you make the same base, and our rule is this. If you have b to the n equals b to the m, okay? Let me show you that. Here's our rule. Here's our rule. It's a math rule. You got the same base, then n equals m, right? You got the same base, x equals 4. See how I did that? So if you got the same base, n has to equal m. You got the same base, x equals 4. Does that make sense? But you got to get the same base. So in a sense, even though Bailey did her head, yay Bailey, you can say, oh, I get it. 381 is 3 to the 4th, so x equals 4. So now let's take a look at example 1. Knowing that, do they have the same base? 3 and 3. Same base, 3 and 3. Do they have the same base? Mm-hmm. So I can just, in a sense, cross them out and go to x plus 1 equals 5, right? Now what do I do? It's easy, right? Minus 1, x equals 4. Boom! Thumbs up on that. Wasn't that easy? So if you get the same base, just cancel them out. Example 2. Before you cancel them out, before there's an invisible, I can't spell, invisible number. There's an invisible number. What's my invisible number? Anybody? I know it's visible. I say anybody see? Yeah. There is a 1. Nice job. See? You can see invisible things, can't you? Thanks, Noah. So before we do anything, there's an invisible number. 1. Good job, Noah. And then base 6, base 6. Cancel them out. So I have a 1 equals 2x minus 3. You can see why we needed that invisible number, right? Had to have it because you needed something on the other side of the equation. Okay, then we just go plus 3. Plus 3, 4 equals 2x. Divide by 2, x equals 2. Good job, Noah. Everybody agree? Now, example 3, they don't have the same base. So either you can see it, some kids do, or you use your chart. Now I'm doing 2's, right? So I got a base 2, I see base 2. So I look at my chart, and I find 32. On my chart, you see 32? 32 is 2 to the 5th. So I'm going to rewrite this as, instead of 32, I'm going to write it as 2 to the 5th power. And maybe you already knew that, right? And maybe you already knew that 2 to the 5th power is 32, but now you get the same base. X equals 5, okay? Okay, how about 4? My base is base 5. base 5. So, 125. Look at your chart. Do you see 125 in there? Base 5, right? Base 5. I go to base 5. Power 3. You guys see that? So the chart really helps a lot. So I'm going to change 125 into 5 to the third. Okay, I still got to remember my x plus 1. So don't forget, I still need my x plus 1. Okay, now, same base, right? So I can just cancel my bases, right? I've got x equals 3 times x plus 1. What do you think? Not too hard? Not too hard so far? And then, you know, 1x, that times that times that. So I'll have a 1x equals 3x plus 3, right? I'm going to solve for x. Minus 3x, minus 3x. Negative 2x equals 3. Divide, x equals negative 3 halves. Or negative 1.5. All right, now, here comes a good one. Raise our brains. You cannot make 27 into a 9. You cannot. You cannot make 27 into a 9, can you? They're close. I'm not going to divide by 3. They're very close. What if we make them both base 3? What if it's base 3, base 3? 9 can be what? What is 9 as base 3? Base 3.
1.
3 squared. Is this 3 squared?
Yes.
What's this? Base 3? So we can look at our chart, base 3. Let's look at our chart. So I'm thinking base 3, right? Thinking base 3. So I'm going to go base 3. So look at my 3's. And there's 9, right? 3 squared. And there's 27, 3 cubed. So base 3, I can make both of these into the same base. See, I found both those numbers? So I'm going to do this. I'm going to go 3 squared and 3 to the third power. And then I'll have 3 squared, but I have to remember my x plus 2. I got 3 cubed, but I have to remember my x, okay? So I change it both into base 3. 9 is 3 squared, 27 is 3 cubed. Once I get the same base, we can cancel them out, right? And I can have a 2 times an x plus 2 equals a 3x. How am I doing? Well, that times that times that. 2x plus 4 equals 3x. Minus 2x minus 2x. 4 equals x, and that's the answer. Cool. Okay, example 6 has a trick, and I'm going to show it. Okay, before I show it, though, think about this. I got a fraction, right? Remember a warm-up? I got a fraction. What happened with the fraction? I had a negative exponent, didn't I? I had a negative exponent. So let me rewrite this. Okay, I am going to do this. On the side, my little side work. Here's my side work. 1/9 is the same as 1 over 3 squared. You okay with that? Okay, here's my little side work. I'm going to highlight that 1/9 over here. Okay, and then that's the same as 3 to the negative 2 power. Because I brought it, make it a negative. Okay, so now 1/9 is the same as 3 to the negative 2 power. I have a 3 to the x minus 4, okay? So just change 1/9 into 3 to the negative 2. Showed that work there. Cancel my bases. Negative 2 equals x minus 4, right? Plus 4 plus 4, 2 equals x. Okay, how am I doing? Okay, Maisie says thumbs up. I only got one thumb up. 2, 3, 4. There we go. There we go. Okay, turn the page. No sideways. Any sideways? Okay. All right, turn the page. All right. Woo! Okay. Now, wow. 36 and 216. Oh, let's see if I can find that anywhere. See if you can find these two numbers in the same base. Oh, we found it in the sixes. Nice job, Bailey. So Bailey found them on the sixes. See them? Bailey found both of these numbers in the sixes. So I'm going to make 36 is 6 squared, and 216 is 6 cubed. Okay? So I'm going to have 1 over 6 cubed, right? Thanks, Bailey. So I still have my 3x plus 3 equals, and I still have my x plus 1. So what do you think I'm going to do next? What do you think I'm going to do next? Yeah.
Instead of that, does it say negative 3x plus 3?
I'm going to bring it up and get negative. Yes, yes. I'm going to bring that up and make it a negative 3.
I'm going to go like the 6 above the 6.
Yeah, it's supposed to be
Oh, I
negative.
missed that negative. Oh, thanks, Artie. I did. Well, I gave away what I was going to do, didn't I? Okay. Thanks, Artie. I did make a mistake, which is pretty typical of me, isn't it? Thanks, Artie. Put negative right in there. I kind of went through it. Now, I'm going to do this. I'm going to go 6 to the 2 times my negative 3x plus 3. Thanks, Artie. Equals 6 to the negative 3 x plus 1. So I wanted to bring it up. So to bring the 6 up, it became a negative exponent, okay? And now, I'm going to get a 2 times a negative 3x plus 3 equals a negative 3 times an x plus 1. This is a hard one. Wasn't that nice? This is a hard one. I can do it though. That times that, negative 6x plus 6 equals negative 3x minus 3. Plus 6x plus 6x. 6 equals 3x minus 3. Plus 3 plus 3. I've got 9 equals 3x. Divide by 3, x equals 3. Hey, that was a good equation. Now, there's some math you cannot do at all unless you graph it. This is an example of an exponential. With a linear. Right? The only way we can do it is by graphing to find out where they intersect. Okay? Now I didn't graph it very well. It may probably intersect somewhere else, right? You can't solve it. You cannot. So it's every now and then you get two totally different kind of functions. One's an exponential, one's linear. And the only way you can graph it or solve it is with Desmos. So I'm gonna grab my phone. You guys have your computer, but I'm gonna go straight to Desmos. And I'm going to try and type both these in. All right, so first of all, I'm going to go y equals 3 to the power of, I'll use parentheses because I learned better, x plus 2, close my parentheses. Okay, and then I'll put a second equation in, y equals x plus 1. Okay. Boy, they didn't intersect at all. Do they intersect anywhere? I got to change that problem because you don't even get it. Well, let me change this for the fun of it. Let's make this an x plus 8. There we go. So I changed it. You could tap on it. There's an answer. You could tap on it. There's an answer. Yeah, I gotta change that because I should probably just change this to 10. I'll do that next year. Doesn't help you guys. Probably should change that to 10. And then I get 2 points of intersection. And I get this. And I get 2 points of intersection, but the only way I can get it is through Desmos. And I get an answer at about 0.105. That's X. And the other one's down here. Tap, tap. And about at -10. Okay. That's all I have for homework. And I want you to work on